And that is you can write, no, I'm good, I'm on full screen. You could write any 4x4 matrix as a linear combination of, we'll just say in terms, of the following matrices. The identity, gamma 5, all of the gamma matrices, the combination of the gamma of one of the gamma matrices and gamma 5, and then one of the sigma matrices. Any 4x4 matrix you can write in terms of those matrices. That's some sort of linear combination of those two. Well, if you look at the problem again, let's do this. If you look at the problem again, we have on the left-hand side a 4x4 matrix. Right? We have a 4x4 times a 4x4 times a 4x4. So, what do you think we should do? Well, let's write it down. Gamma mu, gamma nu, and gamma rho. We can write down a linear combination. How many steps am I skipping here? I don't want to skip too many steps. I want to skip some steps, but I want to make sure they don't skip too many steps. Alright. Well, yeah. I guess I can show all that. Okay. So we can write this in terms of a combination. There is one thing that Langacker says that I don't understand. I could not find out why. In his explanation for this problem, he writes the word clearly and then writes the answer. So he writes this next step that I'm about to show you, and then he writes clearly, and then he writes the answer, which is really frustrating when you're a student trying to learn this stuff. But luckily, if you spend some time working on it, you can bust your way through the identities and come up with, and convince yourself that it's also true. But let me write the first step, and that's basically, the thing that he doesn't really explain. For this particular problem, he says that because there's 3 matrices here, okay, that you only need the following 2 elements. Gamma and gamma times gamma 5. Why? I don't know. I don't know that one rule. I don't know why. Did I cut that off? Oh no, you guys can see that. Okay. I don't know that one rule. But whatever. It's neither here nor there. We're just gonna plug away. I do know that because of that fact, you can then write this following. We look at the first few terms of the equation and we see that they all have a gamma times a g, where g is the metric. G is the metric of, let's see, mu nu, of, I think it's 1, we'll say plus, minus, minus, minus. So if you know metrics, that means plus, and that's a diagonal matrix. It would look basically like, 1, negative 1, negative 1, negative 1. Okay? All the rest are zeros. So that's just the metric for G. That's what G means. So we know that basically what we want is some gamma, we'll call it A, we'll call some A, sigma, times this gamma sigma. Okay? And that will that should hopefully take care of a bunch of those gamma terms. The first 3 terms that just have a gamma times the metric in them, we're gonna venture to guess that this is the right way to begin that part. And then the second part, we're just gonna say B sigma times gamma sigma, gamma 5. Well, why? Well, again, because if you look at the last part of that, you see that there's a gamma sigma and a gamma 5 there. And that's probably what we want to exploit, is that thing right there. So, how do we do it? How do we go from here? Well, firstly, we have to talk about a few of the identities that he gives us. Let's do the Wikipedia ones. I think they're a little bit more solid, because the Wikipedia ones are actually gammas. So I found these on Wikipedia. But we could write the following. If you have the trace of, and this will all make sense when you see what I'm doing here, gamma sigma, gamma mu, gamma nu, and gamma rho, you get the following. 4 times G nu rho G sigma mu plus G mu nu. Oh, should I should show that, shouldn't I? I should show that. We're not going to use this identity. I'm going to show you. I'm going to show you how to find the identity. How about that? That looks a lot more fun. Okay? So let me preface this all by saying why. Well, we're going to rewrite this as A sigma gamma sigma plus B sigma times gamma sigma gamma 5. So basically we've just flip-flopped the indices on both these two terms. Okay? Now, let's talk about this. Firstly, let me make some sort of blanketed statement and say that A is going to take the following shape. A sigma up here, okay? A sigma is going to take the following shape. 1/4 the trace of gamma sigma, gamma mu, gamma nu, gamma rho. Now I know that the trace is basically the sum of the diagonals. If you don't know what trace means, it's just you have some matrix, you multiply all of these 4x4 matrices together, and the trace is the sum of the diagonal, okay? And then, I mean, like, this is a pretty ad hoc thing to say, right? Well, if you were a master of these identities, you might see this right away. But like me, I didn't see this at all. So I wanted to inspect this guy and see what this is about. Well, let's talk about that one. So the trace of gamma sigma, gamma mu, gamma nu, gamma rho. Well, firstly, we have this metric in here, in the answer. And that's something that we need to figure out kind of right away, right? We need to figure out what's going on with the metric. Hold on, I'll bring this up. Yeah, so we have this metric inside the answer. Andrew Dodson's the man. He is. I wish I was as good as him. He's the tensor boy. When did this become Andrew? Anyways, alright. That's funny. I like that. Like I said, we'll go over some easier problems later. They're gonna do some force and stuff like that. We still got a while left on stream, so we got plenty of time to do all sorts of stuff. And maybe my internet might be back. Level 12 tensor boy, yeah. I think my internet might be coming back too. Oh, the sun's shining again. Alright, and I'm like warm. This is like the first time in a long time I'm warm. Alright, so one thing that we do know, let's box this guy. This is going to be something we have to think about. One thing that we do know is that maybe I'll write two things we know. And this is from Langacker again. This is again something that if you wanted to prove, you could prove it. You could prove this if you just took two random gamma matrices. Remember, they are just, like I wrote them before, they are just the matrices. They are 4x4 matrices made up of a 2x2 matrix where two of the elements are Pauli matrices, and you can find all of them online. If you so you could write it like this. You could also write it like this. Now, this one I want to make sure I get right. Gamma mu is equal to G sigma mu gamma sigma. Okay, so now these are a little bit motivating for us to try to take this guy and turn some of these into the metric, right? So how do we do that? Well, let's start with this pair right here. If we have a new row, and here you have a mu new, they anti-commute. We can rewrite this, and we will. I'm going to have to erase all this in a minute so I can have room to write. But we can rewrite this basically as the trace. Let's use rounded brackets. The trace of gamma sigma, gamma mu, and we're going to take this element and we're going to replace it with the other side of this. So if you write out this anti-commutator, you get gamma mu, gamma nu, plus gamma nu, gamma mu, is equal to 2g mu nu. So what we're saying is this gamma nu, gamma rho is going to be equal to 2g, oh, look at my notes, you doofus, nu rho minus gamma rho nu. Oh, I'm sorry. You write that. Gamma rho, gamma nu. So basically we've taken this term, we've seen this anti-commutation relation, and we have rewritten it like this. Why? Well, we can pull out this part. This is just a number, so it can come right out of the trace. And we can rewrite this term as 2g nu rho times the trace of gamma sigma, gamma mu, minus the trace of gamma sigma, gamma mu, gamma rho, and gamma nu. Basically, I applied this to here and I applied this to here. When I apply this to here, this is a number. It comes out of the trace, but this is still another term. Now, we have two separate things here, and we have to take them each. Can you see all that? Yeah, you can see all that. We have to take them each separately, so let's start with this one first. There is another identity, and namely that the trace of two gamma matrices is equal to, can I write it anywhere? Yeah, we'll write it here because we gotta erase everything anyways. The trace of two gamma matrices, we'll call them sigma and mu for the sake of ease, is just equal to 4 g sigma mu. Okay? Very straightforward. Again, this is something that you can prove to yourself if you're ambitious, or you can take the identity for what it's worth. So we have some more identities to box up here. This is an identity, this is an identity, this is an identity. And this is our guess. This is our guess to solve the first part of the problem. But here we are, so we've gone from here to here. And now notice here we have gamma sigma, gamma mu, gamma nu, gamma rho is equal to this first part, which is 2g nu rho times g4 g sigma mu. So that's 8g nu rho g sigma mu. That's the first term. Can you see it? Yes. Then the second term is this guy. Well, let's look very closely. We have gamma sigma, gamma mu, gamma rho, gamma nu. Here we have gamma sigma, gamma mu, gamma nu, gamma rho. The only thing that we did was permute this nu over 1. So by permuting this nu over 1, or I'm sorry, this rho, switching places with the rho and the nu, we get this term of 8 times this metric and this metric. So, we're going to write this out again. Sigma, gamma, mu, gamma, rho, gamma, nu. We're only going to write it out because I'm going to rewrite it at the top. All right. Keep all this stuff in mind as it goes away. So back to the top, we're going to rewrite A. A sigma, we're going to try to write a little smaller. Trace so that we might be able to finish this calculation without erasing again. Mu, gamma, nu, gamma, rho. And what we've done here is made an educated guess because we have an incredibly strong background of identities. And we're testing that guess now, okay? So we started with the trace of gamma sigma, gamma mu, gamma nu, gamma rho is equal to 8 g nu rho g sigma mu minus the trace of gamma sigma gamma nu, mu, gamma rho gamma nu. Now, like I said, here the only thing that happened is we permuted the nu and the rho. Well, what do you think we should do now? Well, let's keep permuting. But this time, so let's ignore this. This is just a number. This is okay. We don't want to do much with this. But this time, let's permute these two. What do you think we're going to get? Well, let's rewrite our first term. G nu rho G sigma mu minus. Well, if we permute the first two, then we're going to get the same thing. We're going to get a G mu rho, and we're just going to permute this thing across to get the same thing. So we'll get a 8 G mu rho, just like we got for the first one. This was the first one, and we got nu rho. Now we have mu rho, and a G for the remainder, sigma nu. And then the trace of these two permuted. Gamma sigma, gamma mu, gamma rho, gamma nu. Nice. Oh, I didn't do it. I didn't permute it. Gotta permute. Gotta permute. Rho, mu. There we go. Well, that's all good and all, but we're still missing one of these G's. You notice that this G showed up and this G showed up, and if you look very closely at the problem, those G's exist. This G exists right, well, here we go. Boop. Nope. Boop, 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 right there. And then the second G exists right here. Boop, boop, boop. So, those G's are showing up in the answer, so far it looks like we might be doing something right. But we have one more G we have to account for. Let's permute one last time. Let's permute these two now. And what do we get? We get 8 G nu rho G sigma mu minus 8 G mu rho G sigma nu minus 8 G sigma rho G mu nu. And, oh, this is not minus now. This is plus. What did I do wrong? This is supposed to be plus. Because this is minus, so when we permute it again, it's going to be minus, minus, plus. Good. It's important to keep track of your pluses. You spend hours looking at those things. But then, again, what's this? Oh, the math. Then again, we have this, minus TR, gamma rho, gamma sigma, gamma mu, gamma nu. Now, here's something that you might not have, that I definitely didn't tell you yet. And that is that I can take these that make it better or worse? That made it worse. I can take these. Hold on, I'm trying to get this to look right. There we go. I can take these and change them around however I want. It's not going to change anything. Okay? So I can take this and I can switch these as long as they're in the same order. I can switch them and it's not going to matter. So this is, so when I say the same order, I mean like I can pull this row and put it at the end. Because ultimately, if you write sigma, mu, nu, and rho, then I can also write rho, sigma, mu, and nu. Those are in the same order. The only difference is, yeah, this row is out front, but it still is the same clockwise thing. Maybe I'll write it like this. Sigma, mu, nu, rho. As long as I'm going around this circle, it's okay. I can start here and go sigma, mu, nu, rho. I can start here and go rho, sigma, mu, and nu. What I can't do is flip like these around. So as long as I follow this circle, I can rearrange these however I want, as long as I follow this circle. So, I'm going to just take this row, I'm going to put it in the back now, and then I get the same thing that I started with. Okay? I get the same set of gamma matrices. So, what does that mean? Well, that means I can add this to both sides, and I can get a 2 times the trace of gamma sigma, gamma mu, gamma nu, gamma rho. Nice. Let's divide both sides by 2. And we get the following identity. I'm just going to erase this so I can save room. 4, 4, 4. We get the following identity. This was what we started with. We wanted to get it into some metrics because we knew we had those in the answer. So we can, so we found out that we can pull this trace over, add it to both sides, it goes away, and the extra one goes away, and now we get an actual number for that term. Okay, so let's keep going. So maybe it was a pretty clever guess that we could use that, and it definitely was because that's in the answer. So I would say it's a pretty clever guess. Because now we're gonna reuse something I said. Let's look at the equation that we had started with, which was this A sigma gamma sigma. Oh, is that the first page or second page? First page. Plus B sigma gamma sigma gamma 5. Okay, let's look at that really quick. And what did we find? What did I do? Did I mix those up? Yeah, I did mix those up. We want... Sorry. We want B sigma, gamma sigma, like that. There we go. Well, we have A sigma right here. And we have this better identity here. So let's write that out. We're going to look at this term really quickly. And let's erase. Let's move up to the top again a little bit here. Keep this identity safe and sound. And we get, we're going to look at this. And that's basically the following. We'll pull the 4 all the way out. And we'll write G nu rho G sigma mu times gamma sigma plus, we're going to write this one now, and it's going to be G sigma rho G mu nu times gamma sigma minus G mu rho G sigma nu gamma sigma. Now, if you remember right, I wrote gamma mu is equal to G sigma mu gamma sigma. This was one of the identities on the last time we had that page. Okay, let's keep going. So this G sigma mu times gamma sigma can be rewritten as gamma mu. This one, these are numbers, so we can just switch them. This can be rewritten as gamma rho. And these can be rewritten as gamma mu. So let's rewrite that, and we get this nice, oh, this is a fourth, so we should divide this by 4 because there's a 4 there. We get this nice term of, and here we go, G nu rho gamma mu plus G mu nu gamma rho minus G mu rho gamma nu. And this is the first term, and if we look at it, where am I? Oh, right there. This takes care of the first 3 terms. We've done it. So this A, this guess that we made at the beginning, because like I said, we're really confident with our ability to see identities. This guess we made, we were able to redeem it to be the first 3 terms. Now what's next? Well, that's this term's next. We just got to double check that one. That's the only thing left. And where'd my eraser go? It's right where it's supposed to be. B sigma gamma sigma gamma 5. This one I'm going to kind of not go very fast, or I'm going to go kind of slow on. I'm sorry. I'm going to skip most of it. B is supposed to be the same thing, except now we have this gamma 5. So it's going to be the trace of, the negative times 1/4 times the trace of gamma sigma, and this is going to be our guess, but like I said, I'm going to skip a lot of this. Gamma mu, gamma nu, gamma rho. Well, if you look at Langacker, he kind of gives the answer away a bit. Firstly, he gives you what it looks like if 5 is in the front. If 5 is in the front, you just get that, I already wrote it down, you get that the Levi-Civita times, that's it, 4i times the Levi-Civita of all those indices, sorry. But the 5 has to be in the front. He also gives you a nice little identity that basically just says that 5 anti-commutes with all the gamma matrices. So we could just say negative gamma 5 gamma mu is equal to gamma mu gamma 5. So it's very easy. We're going to permute gamma sigma with gamma 5. That'll take care of this minus sign. And what does that give us? That gives us 4i Levi-Civita for the terms sigma mu nu rho times gamma sigma gamma 5. And that's the second term. Oh, I should maybe make that bigger. So the second term, like I said, I kind of invoked a lot of, they're really simple. This is an identity right here. These anti-commute. And also, once you get the 5 over here, it's a simple identity. It's just this trace is equal to this number right here. That's it. And we've done it. We've solved this problem.